Hi, welcome to this special video about the correlation between FoodSense Generation 4 and HPLC. So when I say FoodSense Generation 4, first of all, just better define FoodSense Generation 4. This is FoodSense Generation 4. It's sometimes called online a Scoville meter when it's particularly being used to measure the SHU, the Scoville heat units of chili samples. I will be doing a demonstration of this technology in a short while. The other term that I used there was HPLC, high performance liquid chromatography. I used to call it high pressure liquid chromatography, but it seems to have a bit of a name change over the last 20 years. But that said, so today I'm going to be dealing or discussing the correlation between these two different techniques. Now, I obviously have a bias because we're the developers and manufacturers of the FoodSense Generation 4, so we have to put that, not have to, but I will make that comment now. Now, it's probably worth saying that this video really is part of, at ZP, if you're a FoodSense Generation 4 user, then you will get personal online training. You get weekly webinars. This is kind of part of that support. And we also do monthly webinars. So there'll be a monthly webinar that I will talk about shortly. In fact, here it is. Monthly webinars are worth coming along to because we do a much longer demonstration of the technology. We talk a bit more about the kind of underlying science of the technology. So it's probably worth coming to a monthly webinar. And even if you're watching this video post 29th of August 2024, we're always updating the link with the next, let's say, webinar in the series. With that said, we do two on the day, one in the morning, one in the afternoon. The one in the morning always works well for India, South Korea, Australia. The one in the afternoon works well for South America, North America, for example, and also Central America. Now, I am biased, but HPLC, which we're today comparing against, what FoodSense Generation 4 wouldn't exist if HPLC was a perfect technique for measuring the Scoville heat unit of chili samples. And I will talk about the HPLC method now. First thing to say about HPLC, actually, there's it's when people do HPLC, they assume that these samples are homogeneous. And what that means by that is that they essentially prepare one sample and they assume that the sample that they've prepared is representative of the entire batch. Of course, just, when you actually look at a chili sample, or samples of chili, I mean, especially this one, it's clear that there's a heterogeneity in the chilies here. Not so clear in the powder, but when you put a powder underneath a microscope, you soon realize, you've got different granular sizes, and you've different colors. Now the color is not necessarily an indication of the capsaicin, but there's an assumption in HPLC that I take one sample and I get one test, and it is, let's say, that is the result. That's the assumption. Now let's dig into that a little bit more. So first of all, chili samples are heterogeneous. So at ZP, sometimes we multiple samples, especially something like this, that we would, potentially prepare 5 samples on this, because actually the heterogeneity is not the capsaicin is not necessarily evenly distributed through this entire sample. But in HPLC, one sample is taken, one sample is sent to the lab, one sample is extracted, one sample is diluted, one sample is injected onto the HPLC. At which point now, this is actually a bit of a black box to most people, because in fact, you've never witnessed most of the time actually what's happening between you sending that sample and the sample received and the certificate of analysis coming back. The sample's injected. There's some important steps. At ZP, we sometimes work with clients and I get the chromatogram. So at Zimmer & Peacock, we do have a very strong chemistry team. We do understand high performance liquid chromatography. And we actually even get down to looking at the chromatograms themselves. Capsaicin is here, dihydrocapsaicin is here, for example. So we are used to looking at those raw signals. Now, what's important is that actually I have not yet received this from an HPLC house, is the calibration curve, because the chromatogram is kind of the raw signal. I say kind of because I do know that there's some levels below even what I'm calling the raw signal here. But then you have to turn that area under curve, or that peak height, into back into capsaicin. So at some point somebody has done a calibration curve on that. But most of the time, actually, nobody's outside of the HPLC third-party testing house has actually seen that calibration curve. So I would strongly argue that HPLC is expensive. If HPLC was not expensive and it was perfect, there wouldn't be a market for FoodSense Generation 4. I mean, this is retailing at 1/50th the price of HPLC, and it doesn't in any way require the PhD chemist or the master's chemist to run that instrument. It doesn't require the organic solvents to run that instrument. I mean, that instrument does have to be kind of kept in a very laboratory environment because it's a delicate instrument that you can't keep it in a dusty, sort of slightly dirty environment. It has to be kept in a kind of pristine environment. So it's an expensive instrument to own and operate. Therefore, it's an expensive instrument to actually have samples run on. I think the cheapest I've heard of in the USA is $50. I think it's much more typical to have $100. There's no transparency on this, that you just get a certificate of analysis with a number, and that number is given to you as an absolute, that is the number. But of course, with any measurement, there's an uncertainty about it. But when we're given HPLC results, there's actually never any uncertainty indicated. And I don't want to say it takes too long, but actually, what I mean by it takes too long, the gap between sending a sample and receiving a result can easily be up to a month. Now, when we look at the results, sometimes the results we get from an HPLC would be something like an email, maybe a table. Sometimes you may receive a certificate of analysis, and in there you'll get possibly what method they've used. So ASTA 23, I want to say 21.3, but there's an ASTA method, the American Spice Trade Association. There's also this AOAC method, 99.5.03. Just out of interest, I think the parent method is actually this method, and the ASTA method is really just a derivative of this method. We have our Scoville heat units, but it's an absolute number is reported here. There's no chromatogram, so somebody third party like myself could look at it and check it, if I can put it that way. And there's certainly no calibration curve, so it's very hard to sometimes check these numbers. But these numbers are taken as the golden truth. But of course, with anything, there's no indication of accuracy and there's no indication of precision. And what I mean by that is, genuinely, if you're going to make a recording, a chemistry recording, there is always an error associated with it. But with HPLC, the error is never actually indicated. Now, we have recently been working with some people, and these are 4 samples which so there is a sample somewhere. So somewhere in the world there is a sample. That sample, some of it has gone to an HPLC house and some of that has gone to Zimmer and Peacock. That means that those 2 samples are not identical. What I mean by that is this and this are not homogeneous samples. There's not an even distribution of capsaicin in either of these samples. It would be the same for something like this as well, actually. I'll just hold it up. This source is a suspension. There is not an even distribution of capsaicin throughout this. It's easier to shake this and get an even distribution of capsaicin, or argue that there is, so you can make that more homogeneous. Making this homogeneous is actually really hard. So the story here is there is a sample out there. Some of that sample has gone to an HPLC house and some of that sample has come to Zimmer and Peacock. So we're working at samples from the same parent sample, but they're not absolutely the same sample. That's a really important point, because therefore there's an intrinsic difference between what's happening here. But these samples went to the HPLC house, and one of them came back at 3,429 Scoville heat units. Some of them came back, one of the other samples came back at 4,666 Scoville heat units. One of them went out and came back at 21,133 Scoville heat units. And one of them went out and came back at 53,888 Scoville heat units. It's important. So there's a parent sample. Some of it went off to this HPLC house, and they did one test. So in that case, there is no indication of necessarily the one sample, one test. There's no indication of the inherent heterogeneity of the sample. and there's nobody's actually looked at the chromatogram or looked at the calibration curve. But I'm sure those are all very good. So sort of later in time, and later in time is important. So sometime later, some samples came to Zimmer and Peacock, and we've tested those samples, and we got 3,314. Don't worry, I'm going to do a correlation curve at the end of this presentation, so you'll be able to see these HPLC versus FoodSense Generation 4 together. We got 3,314, 5,532, 19,460, 40,920. So later on, we also received samples, but it's probably worth saying that these are not the exact same samples. They are taken from the same sample. They're not run at the same time in the same lab, and they're basically similar samples, but not exactly the same. Done by different people at different times on different continents. No problems. You will see the correlation is good at the end, but I just want to kind of put that out there slightly. I'm now going to do a quick demonstration, because the whole thing about FoodSense Generation 4 is if today you wanted to test something by HPLC, and if you didn't own that HPLC, you would have to get the sample, put it in an envelope, or send, or put it in a little box, send it to the place, pay your fee, wait whilst they process the sample, and wait to get essentially the result back. And you'll probably just get, for every sample, you'll get one result. There won't be any multiple testing, so you'll have no sense of heterogeneity. So what I'm going to now do is just do a quick change of camera. So I will take a sample. Just want to demonstrate here that this is a very different. In fact, what I'm going to do is I'm just going to vortex it back here. So I'm just going to take my sample and just vortex it quickly, because I realize I'm talking about heterogeneity, so I better mix my sample up pretty quick. Now I'm going to put 50 microliters on here. I just want to demonstrate the ease of the workflow for this particular device. My phone here is in Bluetooth connection with that. I'll just give this a name. Right, so I'll just do a summary so far. So the next thing you're going to see is that I'll show a correlation curve between testing on FoodSense Generation 4 and HPLC testing. It's probably worth saying that if you're a diabetic, this is a model, but if you're a diabetic, you can either go to the hospital to have your blood drawn and you can have your glucose measurement taken, or you can be at home and you do a quick finger prick test, you test it and you get a result. FoodSense Generation 4 is very much of that model. So I've now got a result on my phone, but I'm also going to show you that result also goes straight to the cloud. So what I want to do is I need to navigate. Whoops, I went to the wrong place. Navigate to the ZP cloud. What I will do is I'm just going to do a quick refresh on this. Right. Yeah, here it goes. Right, good. So let me do that. Right, so I'm just going to share the other screen. So you can see this screen now. So this is the universal time. So I'm doing this on a Sunday morning in London. So that's the universal time in London. That's the date. So you already get a sense of transparency. This is the operator. This is the raw signal. Beautiful raw signal. There's a good transparency on this particular device. So if I hold my phone up, you can see that on the app, we've rounded it up to, I think 8,000 Scoville heat units. Here you can see it's 7,998. But that's just because we rounded up for a user experience, a simpler user experience. Don't forget that HPLC requires a scientist to inject the sample, get the chromatogram, look the chromatogram up against a calibration curve, which you don't know when that calibration was done, and then they're meant to give you essentially a Scoville heat unit. Well, this just gives you a Scoville heat unit straight out. So I just want to show you the simplicity of the workflow from that. And of course, it's all saved in the cloud. There's great transparency. We can see our raw data. This is a very significant part, that this is transparent. transparent. This is the essentially the FoodSense Generation 4's equivalent of the chromatogram. With that said, let me go back to what this webinar was really about, which is actually what's our correlation in this particular study. So that was a demonstration just to show you the simplicity. So what I have here is a correlation graph between the HPLC. So as I say, ZP did not gather this HPLC data. I'm sure it's perfectly good. It's actually done by a national institution, so I'm not challenging that in any way. I just want to answer the question, what was our correlation in this particular study? This is the FoodSense Generation 4 data, and we have a correlation here of 0.99, an R squared of 0.99. Now, I'm very keen that we get a good correlation with HPLC, but I also want to emphasize that the FoodSense Generation 4 is quick, it's easy, it's extensively lower cost to own and run, and it correlates well with HPLC as well, which is a sort of, which is effectively a bonus. So if you've got any questions of ZP and FoodSense Generation 4, you can see that at ZP we are highly technical. This whole presentation really is about supporting clients and supporting a particular client in this particular case, and you can see that at ZP we do take both the instrument and the science and the data science behind this very seriously. So if you've got any questions, don't hesitate to reach out to us. Okay, thanks very much.